Hi, everybody. I'm Chip Paul with GnuPharma, and we're going to go through a new blog here called What Should We Eat? We're going to get into a lot of detail about the types of foods we should eat and why that's important. This is probably one of the most important blogs I think I've ever done because it's a way that you can begin to take back control of your health. So if you followed us from the first blogs that we did, the blog one is our model of human function. Blog two is really how your immune system works. Blog three is inflammation, oxidative stress, really things that impact us environmentally in our environment, how basically our immune system is reacting to things in our environment. Allergies, things like that. Here, we're going to talk a lot more about food, and in particular, how food might be contributing to our disease states. All right. So what should we eat? And what's the story with food? Do we know this? No, we don't even begin to know what we should eat. We are the product of our diet and environment. Again, if you eat bad stuff and you breathe in bad stuff, you're going to be sick. So what should we eat? What is the good stuff? This question will be paramount to our future health and wellness. And believe me, boys and girls, we don't know what we should eat at all. Okay, so real quick review of the GnuPharma model of human function. So first, we work through four major systems. One's a spiritual system. That's left up to you, the viewer. We'll talk about the three physical systems that we work through. Again, please notice that these systems do talk to each other, and they talk to each other through a series of ancient neuroreceptors called FFARs and PPARs, which are still kind of a pharma target. Okay, so let's talk about these systems real quick. So I'll talk about the first one, well, really the second one. So the second system is something called your endocannabinoid system. Again, it is our master regulatory system. 3 points about it. It's really super duper old. We developed it when we went from an invertebrate to a vertebrate, and we share it with most life on the planet. So your dog has one, your fish has one, your bird has one, your reptile has one, and your friend Betty has one. So we all, for the most part, most life on the planet, everything except insects has an endocannabinoid system. Should tell us all how super duper important it is. Point two about it is it's looking to be our master regulatory system. Again, you can satisfy yourself to the amount of research, NIH.gov, and the magic word endocannabinoid. The big thing there is, though, hypothalamus hippocampus kind of acts like the computer in our vehicle, and we use the endocannabinoid system to monitor and then make changes within our body. So it basically is responsible for all of our regulatory function and process, either directly or indirectly. Point three about the endocannabinoid system, and this is why we start with number two rather than number one, is it's driven and fed by natural resources, in particular, fats. So did we have a system before we had the endocannabinoid system that might have fed it? Yeah, it turns out we did. And again, in this C-squirt where we developed an endocannabinoid system, we had a system of fats, a way to store energy and chemical mediators for future use. And we do that in a fat cell on something called a triglyceride. On a triglyceride is made up of a sugar backbone called glycerol. And you can stick three different kinds of fatty acids on a triglyceride. You can stick saturated fat. You can stick monounsaturated fat. The only kind of fat you gotta stick on one are called polyunsaturated fatty acids, omega-3 and omega-6 fatty acids. So again, you build triglycerides, they're only as good as what you put in your mouth. And again, we need a balance of fats so that we can have a balanced triglyceride situation, which we don't even begin to understand at this point. But anyway, for now, these fats that we put on a triglyceride, we do something called metabolize. So we'll take a triglyceride, we'll pull off the fat, and let's talk about saturated fat. So we'll pull off, let's say, a saturated fat, big, long fatty acid. We pull that into a cell through metabolism. And based on the RNA and DNA in that cell will express scissors, let's call them, called enzymes. And those enzymes will take that big old long thing and cut him up into littler things. So in this example, again, we can use the example of saturated fat. Saturated fat can be metabolized into cholesterol. cholesterol can be metabolized into progesterone. Progesterone can be metabolized into testosterone. I think cholesterol can be directly metabolized into estrogen. Cholesterol can be metabolized into vitamin D. We're all vitamin D deficient. That's what the pharma is telling us all the time. That kind of indicates that we're probably cholesterol deficient, that, believe it or not, and that kind of probably indicates we're saturated fat deficient, or we're deficient in the cofactors we need to perform metabolism. And we do need some cofactors like oxygen and an ion. And where do we get that ion? We get it from a metal, usually from zinc or iron. Okay, so this is really cool. So how does system 1, the fat system, tie to system 2, your master regulatory system? Well, really tightly and really closely. If this was like, that takes 12 enzyme steps to break down all your stuff on a triglyceride into endocannabinoid, you'd think, they're not really closely related. One enzyme step, however, tells you they are directly evolutionarily linked. So again, when we needed something to control, we developed an endocannabinoid system, which is directly one enzyme step directly fed by a triglyceride. In particular, saturated fats break down into something called PEA, which is an endocannabinoid. You can look him up. He's responsible for inflammatory control, a lot of good stuff. Monounsaturated fatty acids break down into something called OEA. OEA is responsible for our circadian rhythms, a lot of how we regulate our body. Our clock enzymes, our clock genes are related to oleomide directly. Oleomide also hits the ancient PPAR system. So again, this is how we signal between our gut and our endocannabinoid system and the endocannabinoid in the fat-based system. Sorry, almost said endocannabinoid twice. And then polyunsaturated fatty acids. So these are the only things we got to have. Again, omega-3 and omega-6s. Omega-6s, we're going to talk about how they're bad. They're also good. They break down into endocannabinoids, anandamide and something called 2-AG. And again, these are very, very important. Anandamide is how you regulate your body. It's how you hit a CB1 neuroreceptor to do work in your body. If you're a cannabis person, again, we're not talking about cannabis at all, but if you are, THC mimics anandamide. That's why it's useful and valuable. But anyway, omega-3 and omega-6s break down into, or omega-6s break down into 2-AG and AEA, which is called anandamide. But all of these things fuel your endocannabinoid system. In fact, you don't make anything for your endocannabinoid system other than the things that come from fats, which is cool. All right, so the third physical system is a bacterial system. Again, it's a sugar system. It runs on sugars, carbohydrates, and basically non-digestible fibers. So a lot of the bacteria that will grow in our guts need fiber to eat. And basically, if we give them fiber to eat, they give us some beneficial chemicals. All of the chemicals that you need to run your body come from a triglyceride. So everything you need to regulate your body function comes from a triglyceride. Everything that you need to regulate your mind, your mental function, your cognition, come from chemicals that you make in your gut. So you'll want to keep these bacteria happy. You don't want to piss them off. If you piss them off, they're going to cause you to be depressed or anxious or other things, okay? So, but these bacteria do respond directly to our diet and should. This is how we basically configure our mobile, how we respond to things, how we respond to the delicacy of our environment and our diet. Okay, so let's talk about that. How do genetics work? Are we born with a set of genes that never change? No. Again, that's what science would lead you to believe. Oh, it's a genetic mutation. You're screwed. Oh, it's a genetic misfiring. You're done. That happens all the time. You can, again, genes mutate all the time. I could create oxidative stress and cause certain genes to mutate inside of anyone right now. You could too. Oxidative stress does it. So here's the deal, guys. So it's as simple as this. You're born with something called a phenotype, which is like your template, but you're constantly changing around that template. So let's take you on a little journey. Let's go on a little example. Let's go on a little walk. So you and I decide to go on a walk, and we're walking down the road. And as we're walking down the road, we walk over a lead mine. Oh no, but we don't know it. We're walking down the road, we're chatting, we're having a good conversation. But as soon as we take in that first breath over the lead mine, our respiratory system knows it. Our respiratory system immediately senses the lead through something called our TRP channel. And we start making all these genetic changes based on the lead. We start turning on DNA repair genes called certain genes. We start turning on oxidative stress genes. We start turning on genes to defend ourselves against xenobiotics, is what it's called, things that might hurt us. So we turn on all this machinery. And when we turn on all this machinery, we have a limited amount of resources. And we start pulling resources. We start pulling oxygen and metal ions and all the things that we need to run our normal function over here into these emergency genes that are going off like crazy. We don't know it. We're walking down the road, just having a nice conversation. We walk off the lead mine. What happens? All this shuts down. All these cofactors go back to our normal function, and we go back to normal. We're built to do that. We're built to respond to our environment. It's only when we have persistence in our environment that we have trouble. So if I gave you a piece of lead to walk around with all the time, hold in your pocket, that would cause you a disease state because your mobile gets disrupted. You find a new normal, but you're sucking up resources to do it. Okay. Again, what is a disease state? Well, I kind of just described it, but again, we'll go with the Wikipedia definition, which says a disease is a particular abnormal condition that negatively affects the structure or function of all or part of an organism, and that is not due to any immediate external injury. Okay, so a disease is a dysregulation. A disease is basically a state of being that is not normal. And it's not caused by getting hit on the head. It can be maybe later. Okay, so what should we eat? All right, well, first we need to realize how delicate and resilient that our nature is. And we just talked about that with a lead mine example. So again, we're kind of like a mobile, and we're built to adjust to, walking over a lead mine, but walking off of it. We're built to adjust to eating things that might be poison. We're built to adjust to infections and, parasites and things like COVID, foreign viral infections. We're built to do that. Our immune system is built to adapt and basically to respond to those things. We just learned about basically fats and sugars. So how does that factor into all of this immune system and kind of how it works? How would we optimize our diet to have the best mobile we possibly could? And again, what in the body is a mechanism for change as we change our diet? So how can we configure this, I guess, is, what I'm saying, and is it easy to configure? Well, let's talk about kind of how it goes wrong first, and we'll talk about kind of how it goes right. All right, so fats, as we mentioned, fats are triglycerides, or, real quick on fats. So again, I hate to go through this explanation, but a lot of people don't know this, so we'll go through. So fats are fat cells. And what are fat cells? We've all heard of LDL and HDL, right? So LDL is bad cholesterol and HDL is good cholesterol. Well, what are LDL and HDL? They're fat cells. And again, there's a few VLDLs and there's a few other types of fat cells, but LDLs and HDLs are the ones we know most about. So let me talk about those. So again, if you have high cholesterol, someone has measured your LDL and they've said, oh, you have a lot of LDL. That means you have high cholesterol. That's not what it means at all. It just means you have high LDL. And why would you have high LDL? You would have high LDL if your body needed cholesterol or if your body needed triglycerides. Because what it does is it asks, again, hypothalamus hippocampus, kind of the commander in your vehicle, but your body will say, give me some triglycerides. And your liver will go, round them up, boys. And it'll get a bunch and it'll go, boom, and it'll release a bunch of triglycerides into your serum blood in something called an LDL. All right. So if you have high LDL, it just means that your body is calling for cholesterol or triglycerides. You're trying to do work. Anytime you're exercising, you're going to have high LDL. Again, the thing that's important is the reclaim. So the reclaim is HDL, and it's more important, the reclaim ratio, than it is the numbers. So if you're calling for cholesterol and triglycerides and reclaiming them in HDLs, that's what you want to have happen. That's how your body works. That's your shuttle, basically, to get energy and chemical mediators to muscles and all different kinds of places in your body. That's how you work. Cholesterol, super duper important. You know, we just heard about cholesterol will metabolize into all of our sex hormones. Cholesterol metabolizes into vitamin D. Cholesterol structurally is important, you know, in our brain. It's 40% of our brain. I think 20% of our cholesterol is in our brain. So, or maybe it's the other way around. But anyway, it's structurally important in our brain. You don't want to, statin drugs will eat it up, and will eat it up in your brain. Okay, so saturated fats, again, they break down into cholesterol and sex hormones. Monounsaturated fats help with inflammation control and circadian rhythms. Polyunsaturated fats help with endocannabinoids, and then our initial pro and anti-inflammatories. So again, it's how we work our immune system when things go wrong. Okay, and we want to have an immune system that responds. So real quick, I don't think I have this slide in here, and I'll talk about this in a second. Okay, so what are the types of fats? Well, again, saturated, monounsaturated, and polyunsaturated. They can come in different forms, and these are the forms of fatty acids. Again, alpha linolenic acid is going to be a different type of omega-3 fatty acid than DHA or EPA. So when we say omega-3, that could be EPA, DHA, or alpha linolenic acid. So there's, you know, some subcategories here. Arachidonic acid is actually a breakdown of omega-6 fatty acids, and arachidonic acid is where endocannabinoids, or your main endocannabinoids, come from. So anyway, these are the types of fats. So these are the things that you're going to pop on a triglyceride. All right, so what else can we eat that's important to eat? And what we're going to do is basically go through the types of things that should be in our diet. So fats, and those are the types of fats. Proteins, we're going to talk a little bit about proteins. But again, proteins, what proteins are is really other animals' triglycerides and the cofactors that they need to build those triglycerides. So when you build muscle, you're basically building this situation where, you know, you're building that in protein, but it's got a bunch of basically, you know, highly compacted, let's say, nutrients in there as protein. So protein is the main constituent of all living cells. So it's you know, how we basically build muscle and things like that. It's the largest component of our diet, and probably should be. When we metabolize proteins, we release ammonia, and this is kind of important. So you've heard of urea. We have to be able to deal with ammonia as basically an organism and convert it into something that's non-toxic. If we don't, we create oxidative stress, which will create other bad things. And again, oxidative stress and inflammation are the two biggest things that are getting us right now in our environment. Okay, so in protein, it used to be thought that there were 9 essential amino acids. So again, you've got to have, when these are essential amino, you have to have these amino acids to function. So again, these amino acids do things, but again, your body can also make them, and your body can make these from, get this, sugars from bacterial processes in your guts. So a lot of these proteins that we need, basically because of the essential amino acids, it turns out that these amino acids are also made in our guts and are part of kind of the chemical processes that go on in our muscles and things like that, which is why they're stored there and why we get them in basically meats from other animals as proteins. Okay. Makes sense. Hopefully makes sense. So, and again, are they eaten or made? They're both. Proteins, again, we can eat them, so we can get these things from other animals, but they certainly are made, and they're made by bacterial processes in our guts. So what are the types of proteins? Again, you can see them there. We make all of the chemicals that we need to run our mind from tryptophan, tyrosine, and phenylalanine. So they're on the bottom part of that graph there. And most of these other basically types of proteins are breakdowns of those three. So in a perfect diet, we really want our diet in our guts, at least, we want to be making tryptophan, phenylalanine, and tyrosine in proper ratios and, basically proper boundaries. Okay, so carbohydrates, again, now we're talking directly about sugars. So carbohydrates are literally hydrates of carbon. These are sugars, polysaccharides. So basically anything that is a sugar. So glycerol, the back of a triglyceride is formed from carbohydrates. Okay. So what are the types of carbohydrates? Glucose, fructose, galactose, lactose, mannose, and sucrose. Glucose is how we form that glyceride portion of a triglyceride. Okay. Fructose is something that occurs in fruit and is similar to glucose. It looks a lot like to our body, like glucose. So our body will use fructose in a similar way that it uses glucose. However, fructose is meant to be rate limited, and fructose is rate limited by citric acid. So again, if you're eating fruit, in fruit, there's going to be a rate limiter called citric acid that's going to tell your body to kind of stop processing sugar and go back. In the fasting fed, you go through the sugar fat process. And again, you want to be processing fats mainly. You want to process sugars to build fats and store fats, but then you want to go back to processing fats. If you don't, you get obese. Again, if we eat too much sugar and this gets dysregulated, this is what metabolic syndrome is, where we get in a pattern. Basically, our mobile becomes disrupted because of what we're eating. And we get in this pattern where we're running more on sugar than we are on fats. So our body adapts to that new environment. And that's not a good situation. It's literally called metabolic syndrome. Okay, so food and genetics. So we're going to talk a lot about this. And at what point are we holding lead? So let's dive in. And at what point, or what you're putting in your body, your food sources, causing you to react just like you're holding a piece of lead. And we don't want that. Well, let's start with inflammation. So there is no question that inflammation is the leading cause of death in humans. Okay. So that's the bottom line. And again, you can look at heart disease is in the inflammation category. So heart disease is in there. What are the causes of heart disease? So heart disease is the leading cause of death in the United States, but really it's inflammation, because it's, inflammation is just a broader category. But what are the causes of heart disease? Well, it's obesity and diabetes, which are inflammation and caused by inflammation. 25% of us will die of a heart attack, a heart-related disease. 13% of us suffer from diabetes. 34% of us have pre-diabetes. That falls right within that statistic, doesn't it? 42% of us are suffering from obesity. 74% of us are getting ready to suffer from obesity, so we're overweight. And again, we may not trust the CDC anymore, but we used to. So these are CDC statistics. So they're, from the horse's mouth, so to speak, unless you're talking about other things, and then maybe not. Okay, so high carbohydrate diets, what do? Well, they could be high in fructose. And again, everybody should begin checking their labels for fructose, corn syrup, high fructose corn syrup, right? So we don't want to eat corn syrup. We do not want to eat fructose. It is not a natural thing. Your high carbohydrate diet could be high in sugar, and it could be high in alcohol. All of these things, high carb diets, high sugar diets, cause your body to work as it was designed. You will run, you will burn the sugar, you will store any fats that you eat. You will become obese in abundance. This is the way we're designed to run. This is something that's happening to us all, called metabolic syndrome. So again, high carb diets, 100% linked to metabolic syndrome. Metabolic syndrome is 100% linked to oxidative stress and inflammation. Loop, 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 loop. But again, our diet is causing these things, right? So it's not inflammation causes bad diet. No. Okay, so sugar and inflammation, let's just press on. So does sugar cause inflammation in the body? People with diets rich in refined sugar may be increasing their risk of chronic inflammation. Research suggests that when people eat and drink less sugar, inflammatory markers in their blood decrease. So again, sugar drinks increase inflammation. Sugar promotes the liver to make free fatty acids. Fatty acids, when processed, produce pro-inflammatories. So what is this loop and what does this loop look like? Well, let's talk about it. So again, our diet has a significant impact on inflammation. If you're not eating things that help you mediate inflammation, you won't. You can't magically build anti-inflammatories. You have to eat the things that you need to be able to build anti-inflammatories. Too many saturated fats can absolutely cause inflammation. If you overeat, which all of us do in our diet now, omega-6 fatty acids, that will cause inflammation. Again, when you have, it's like a balance between omega-3 and omega-6 fatty acids. If you eat too many omega-6s, your body will react with too much inflammation. If you eat too many omega-3s, you will not be able to inflame, okay? It works in balance. So we have to have these in balance. Right now, we have way too many O6s, so we stay inflamed. Our food is killing us, basically, is what I'm saying here. And again, 10% of our diet is way too much to have basically these fatty acids, omega-6s in our diet at 10% is way too much. Now, here's another thing to kind of warn you about is heated omega-6 products produce toxic oxidation products, okay? Toxic oxidation products. Now, do we have omega-6s in our food sources? Well, again, I just listed a few here, but you can pull this up on the internet and not to, go at a particular food chain or anything, but gosh, right off the bat, you see some, big food chain there that has a lot of fatty acids and a lot of things. Now, I want you to look down though real quick at the chicken McNuggets, right? So they have quite a bit of fatty acid in them. I just told you that when you heat fatty acids, you oxidize them and they become toxic poisons. What happens when you fry those McNuggets? What if the oil that you fry those McNuggets in has omega-6s in it? And it does. They turn into poisons, okay? So this is unfried, unoxygenated omega-6, but just this is kind of how, again, we need it. We got to have it. We build endocannabinoids from omega-6s, so we got to have omega-6s. We need endocannabinoids to regulate our body. So we have to have some, but again, everything is a balance in nature, right? So I want you to look at this graph. In 1910, our average consumption of omega-6s was 10 grams, okay? And that's probably about in line with where we should be. It's probably actually a little too much, but about 10 grams. What is it today? It's 4 times that. It's 40 grams, okay? If you look at correlation, the graph on the right is just how much this has gone up. So what percentage of basically our subcutaneous fat. So how many omega-6s are we sticking on triglycerides? How much does our body have to work with? This is stored fat, okay? And look at that increase from just 1960, okay? 1960, we were right in line with a chimp. And again, is that about where we should be? Probably, our closest relative in the wild. And we were right in line with where a chimp is. And look at how divergent we are. So again, does a chimp get sick in the wild? Does a chimp get IBS? Does a chimp get autoimmunes? Does a chimp get all the things that afflict us? No. I mean, they might get eaten. They might get a virus, but they don't get sick from their food like we do. Okay, so what do we do? How do we fix this problem? Well, again, until we really have the proper things in our diet, it's going to be hard to do. It's all about building a proper triglyceride. But until we have the proper food sources in our diet, we're going to have to supplement. Okay. And so let's talk that through. So again, we want to build a proper triglyceride. So we want to put the proper ratio of omega-3 and omega-6s on a triglyceride. How do we do that? Well, we eat the proper ratio of omega-3 and omega-6 fatty acids. And in relation to that, we also eat the proper ratios of monounsaturated fatty acids and saturated fatty acids. So we optimize, we eat for a triglyceride. How novel is that? Again, things that are also we're going to have cofactors. So we need ions, and our ions come from iron and zinc. We need oxygen, those come from our respiration, and we need some micronutrients, and those come from rare earth metals, things that we used to get in our food that we don't get anymore. Things that also help, and these mainly help because they support the other things, but things like turmeric, sage, ginger, rosemary. So again, we need to go back to heavy spices, really go back to our spice cabinet and use these spices heavily in the things that we eat. Cannabinoids also help here. Again, THCA, super good cannabinoid. CBD and CBDA, super duper good. THC, not so much. Again, it's going to help your body do work. If your body's sick and trying to get sicker, it's going to help your body do that. If your body's trying to get better, it's going to help your body do that. So THC will just help your body do work because it mimics your main worker called an anandamide. But THCA actually hits PPAR receptors. So these receptors that help balance all these systems. And that I would wager, I don't think there's research there, would be far more efficacious. Okay, so again, where's all this going though? Well, diet, again, we've got to build this proper triglyceride. Well, if our meat, where we get most of our triglycerides, is eating the same crap we eat, they're building the same crappy triglycerides that we're building. So until we kind of get our meat right, we're going to have to supplement. Well, how do we get our meat right? I've read a lot of studies. Again, we can get our meat right by understanding diet again. So if our meat eats a lot of omega-3s, our meat will store omega-3s on their triglycerides. And by virtue, when we eat that meat, we will get those omega-3s. It's really kind of that simple. And again, if you can't pick it or shoot it, don't eat it. That's a pretty simple dietary thing. There's nuances within there if you have some problems. And again, you should be careful of certain things. But we need to fix our meat. So again, our meat needs to be eating what we eat or supplementing with what we supplement in a perfect world, or we just need to understand that better. So for instance, if our meat eats chia, look it up. Go on Google. What happens when cattle eat chia, or a horse eats chia? Although a horse isn't our meat, or chicken eats chia, or a pig eats chia seed. I think you'll be fascinated by what happens. Again, we need to cut out the sugars. Sugar is an artificial substance. It doesn't occur in nature. I mean, we make it, synthesize it from a sugar cane, but it doesn't. Sugar canes occur in nature, but again, sugar is synthesized. Fructose is synthesized. When you eat a piece of fruit, it's got goodies in there that limit how long you will process the sugar in that fruit, something called citric acid. So again, if we just eat sugar without citric acid, we're fooling our bodies into running on sugar all the time and storing fats. Not good. Again, we're not really built to eat grains. They're these stable, potentially allergic molecules. So, the more grains you can cut out, the better. Chia seeds actually make a pretty good flour. Again, there's something in unsprouted seeds called phytic acid that you need to be a little bit concerned about. But again, past that, seeds are a good source of nutrients. Again, we need to cut out corn and other grains, and we need to super duper spice up our food. So again, all of these spices, why are they medicinal? They're medicinal because they support basically all these systems, either at a fine level or at a higher level. And again, we should all be eating hemp powder. Very good thing to eat. It's non-psychoactive. It's not going to hurt us. Uber duper safe, uber duper healthy. THCA, CBDA, super good to do. All right. So if you guys want to learn more, we have monthly classes. I think we're going to start probably having weekly free classes because you just need to get this info out. I think it's important info. And again, hopefully I've sparked some things in you. You're going to go off and create some cool new products or something to help us fix all this. I just knocked over my microphone. If you need to find us, you can find us at GnuPharma.com. If you need to buy products from us, again, we take all this science and build products with them. And you can find those at TrueMedics.com. You can also find us online, social media, /GnuPharma/TrueMedics. Anyway, you can see us on our YouTube channel down there. Watch blog 1, watch blog 2, watch blog 3. This is blog 4. See you guys. Thank you.